Hi, this is a presentation about interlinking between two data sets on the web of data. In the linked data context, we have some tools that they can perform interlinking between two data sets, and they can discover similarities between two data sets according to the conditions that an expert specifies in the configuration file. So the interlinking process is as follows. We have some data sets. For example, we have a source and target data set, and there are some filtering conditions. And you want to find similarity between two data sets. For example, we have from one side, we have a data set in, let's say, e-learning context, and the target we have the Wikipedia, and we want to know that whether there is any possibility to link some of these resources to the Wikipedia or other data sets as well. So the interlinking tools perform the interlinking according to discover some similarity between the data items in two data sets. So they use some um, matching algorithms to find the string similarity between two terms, and finally after this discovery they give the results in table format, and their output is, for example, one term in the source dataset is equal to or another term in a target dataset as well, and the human experts can review the results, and they can filter out the useless results as well. The interlinking between two data sets, I selected two data sets in the Data Hub. One of them is ODS, which is a project about e-learning, and it contains around 600,000 metadata records. The metadata records in the ODS is according to IEEE LIMES, which is a schema for describing e-learning objects in e-learning context. So these metadata are according to IEEE law. So in this project, they expose their metadata according a specific ontology on IEEE LAM schema. As you can see here, there are some metadata elements that they use for exposure. Here they have title, keywords, identifier, and technical location of the resource or something like that. So there are some metadata records that we can use for the interlinking. We should be careful because we should know that what type of metadata we want to use or what type of entity we want to use for interlinking. Here, as you can see, there are some elements, and as you can see in the values, there are some strings that you can use for the interlinking. And here we think that title of the e-learning resource and title of the object is most appropriate for interlinking to find some similarity between these e-learning resource and the target datasets. And this is a Sparkle endpoint of these data sets. So this Sparkle endpoint can be used for the queries for the users. On the other hand, we should find another data set for interlinking. We have a LearnWeb here, which is a system in the e-learning context, and includes 1,000 of the e-learning objects as well. If we explore one of the resources, you can see that the metadata schema is doubling core, and there are some values for each metadata. And as you can see, it has a format, for example, publisher, source, and title as well. So something that we want to consider between these two data sets is title of the e-learning object. We want to find some similarities between the previous data sets and LearnWeb data sets. So as we can consider the sparkle endpoint, we can explore the sparkle endpoint, and we can see that okay, this sparkle endpoint is active. For ODS is also is active, and we can find some e-learning resource here as well. So knowing these data set, we should use an interlinking tool for finding discovery, for discovery between these two data sets. We used LIMES, which is an interlinking tool, link discovery framework for metric spaces. So the previous version of LIMES was a interlinking tool, which includes a command line tool that you can find similarity between two terms. So the new version of this, the LIMES is same, which you can see here. It has a demo, and you can play with this new version as well. But for our experimentation, we use the previous version of LIMES, which is a command line. And we want to know how we can perform the interlinking between these two data sets as well. So for these cases, we need to download LIMES. I have the LIMES version 0.6, and in this tool you find some libraries and some jar files. So to run this interlinking tool, you need the Java machine on your Java library in your machine to run this tool as well. So for this case, first of all, we should provide a specification and configuration in the LIMES. Here I have a configuration file of the LIMES. You can use one of the template of LIMES, because LIMES has a actually a user manual. You can open the user manual, you can follow the instruction that how you can do interlinking between two data sets here, and there are some functions and notes that you should take care of. So here I use the template to perform the interlinking between two data sets as well. This configuration file is an XML. So in the first part, you have some prefix that you want to use. Now, for example, I wrote many prefixes that I don't use it actually. So those prefix that you want to use in your queries, you can write the prefix here, the namespace and the label that you want to use. After the prefix section is the section for the source datasets. And afterwards, you have the section for target datasets, the metrics and the matching algorithm, the condition for acceptance, and the condition for the review of the results as well. So after the prefix section, we have the source. Here we can provide the specification for first dataset. So it doesn't matter that which one is your first dataset. You can select one of them. You can write the name of the dataset here and the endpoint here. If you have the RTF dump, you can provide the full path of the RTF dump here, and you should add the endpoint type here, and you can write here, for example, type, which is if the type of the RTF dump is turtle, you can find right here the extension of the RTF dump. Here we use Sparkle endpoint URL. So I write the endpoint of this data set here, and this is the variable that we want to use for the query. You can leave it as it is. The page size for retrieving data of this endpoint, and the restrictions and the filtering options in your Sparkle query you can provide here. I explained about this restriction in the next step. But here you should provide the property that you want to interlink. So And because this dataset provide the title of the learning objects in this term title, so I provide this information here as a DC term title. So I have provided DC term prefix here. I just write it here, DC term title. And because these data set provide their information in English, so we don't need to provide a language restriction here. And we want to consider all these titles in a lowercase. After specifying the source dataset, we go for the target dataset. Again, we write the name of the datasets, the endpoint URL, and the variable that we want to use for comparing. And here restriction, in this dataset we have a lot of resource but in different languages. So I wrote a filter query, a filter condition here to filter out those resources that are not in English. So the goal here is to compare the English titles of the learning objects between two datasets. Again, the property here is DC term, and the entity is title in lowercase. After specifying the target dataset, we go for the metrics. There are a lot of metrics that you can use here in user manual. You can find out that what's the difference between these metrics. But I used the Levenstein distance, which is a algorithm for finding discovery between two strings. And I specified my variable from the first dataset and the property. So it was this term title for the first dataset, and again this term title in the second one. You can use here the other property as well, but you should use the most appropriate one. If it is RDFS label, you should specify your RDF label. And the threshold. What the threshold means that we want to find similarity between these two data sets according to this function and this criteria. Acceptance means that in which under which criteria we want to find these two terms as matched. Here is 90%. It means that if the interlinking tool finds two terms with more than 90% similarity, consider these two terms as matched and writes the output the terms. So, and this is the file that we want to see the results, and this is the relationship between two terms. So it says that okay, the first term is same as the next one. There are other relationships that you can use, but all same as is the most popular relationship that you can use for two terms. There is also another option that you can provide those results that have less similarity. For example, here I specified 0.5, which means that if two terms have less than or more than 50% similarity, the tool should provide the result in another file. So the execution is simple, and leave the other configuration as it is. You can specify the format of the result extension. Here, for example, is empty file. You can actually specify the turtle format for the result, and afterwards you can run the interlinking tool. The LIMES, for the running LIMES, we use Java. So I write the Java command line here, and I specify actually the memory that we want to allocate to this jar file, the name of the jar file, and the name of the configuration file, which is an XML file. So I write this information here, and I run the tool, and the tool starts to read the data from the first data set in this page size 1000 that I specified in the configuration file. So it reads from the first data sets, and when it finished, here it finished, it goes to another data set and read the entities that we mentioned. So it starts to read the TC term title in both targets. So because the number of the triples of the second data set is really huge, and I have run this tool before, I show you the result for you here. Now, as you can see, retrieve uh, around 150,000 triples, and it gets this information here. And as you can see, around 300, more than 300 links have been retrieved as a matched results, and there are some results for the review. So as you can see, 360 matched results were above the acceptance, while this number was for the review. So after the interlinking tool was finished, we can go to the interlinking results. I can also show you the log file. That's something have been run here. So this is a log file that LIMES generated. So you can you can see the result in NT format. As you can see, it wrote the information here in the file, and the left side is the term in the source dataset, and the right side is the term in the target dataset, and they are connected to each other using all same as relationships. So if we review the results, we can get information from both targets. For example, if I click on this URL, you can be redirected to the learning resource page. And you can see that, for example, here the title is San Francisco. So we assume that the target of these datasets is San Francisco, and we can get more information according to these results. So you can polish this information, you can import this information to an Excel files, and you can provide this information to the data providers, and they can filter out those results that are not exactly the same, or semantically they are not the same, because these interlinking tools provide the string matching similarities. So it should be reviewed by the um, actually by the human experts as well. So after this interlinking, you can get more information about these results. For example, here we have the link to the identifier of the resource. If you want to have more information about each resource, you can write a query. For example, to get the actual URL of the learning resource here, or for example, the description of the resource, each resource, or something like that. You can write this query, and you can write the queries here, and you can get the results, and you can analyze the results as well. So running the interlinking tool includes several steps. The first step is configuration the tool, which is we use the XML files for the configuration here. The second part is running the interlinking tools, which it depends. It depends to the size of the triples, RTF dumps, and the data sets as well. So it takes time. Maybe it depends to the equipment that you have. But after running the interlinking tool, most of the interlinking tool provided the information in a text file, and you can analyze them. And afterwards, if you want to provide this link to your actual data set, you can polish the result. You can provide more information about the targets by getting query, And finally, you can adjust this information to the source data set as well. And then you can provide this information in one of the resource here, and you can say, okay, this data set or this information is same as the information in another data sets here. Okay, I hope this presentation helps you to run interlinking tool as well.